All right, so y'all, like I said, this is 1.4, and we'll be doing what we call solving inequalities. So the inequalities I'll be looking at is your greater than, less than, greater than or equals, less than or equals. So remember, this is greater than, less than, greater than or equals, and then less than or equals. Okay, so before I actually start solving the equations, we're going to look at how to determine if numbers are solutions to the inequalities. And then I'm going to show you what we call interval notation, which is another way to represent answers, okay? Because less than and greater than type questions can have more than one answer that makes them true. So for this first example, we're going to determine if the given numbers are solutions of the inequality. If a number is a solution, then it must result in a true statement. When we plug that number into the inequality. Okay, so the inequality they're giving us is going to be x minus 1 is greater than or equal to 6. Then they put a semicolon, and the numbers they want me to check are -3, 0, 4, and 16. So they're giving us 4 numbers to check. So first of all, they'll ask you, is -3 a solution? We'll put yes or no. Then they'll ask us, is 0 a solution? And so on. So y'all, we're going to start with -3. To check if -3 is a solution, I'm going to put -3 in for this x and see if I get a true statement, okay? So I'm going to plug -3 in for the x. So I'm going to have -3 minus 1 has to be greater than or equal to 6. All the work on this problem is done on the left side. So if you take -3, subtract 1, you will get a -4 greater than or equal to 6. Is that true or false? And y'all remember this, if you're looking at a number line, so you're looking at a number line here. Remember, this thing goes on forever in each direction. All right, let me see if my chat's got an answer. All right, so good job. The chat's saying false. This is definitely false, which means it is no, it's not a solution. But y'all, if you're looking at a number line, any number to the right of another number, so any number to the right of another number is greater than that number. So on my number line, greater than are numbers that head off to the right. Less than will be my numbers that head off to the left, okay? So now let's try 0. So to check 0, I'm going to put a 0 in for my x again. So I'm going to have 0 minus 1 has to be greater than or equal to 6. We are working that left side. 0 minus 1 gives me a -1, greater than or equal to 6. So now you got to ask yourself, is that true or false?
It's false.
All right, so you are lighting up the chat. Definitely, good job. This is definitely false. So that means no, 0 is not a solution. All right, y'all, our next number they wanted me to check was 4. So I'm going to put a 4 in for the x. I get 4 minus 1 has to be greater than or equal to 6. All right, y'all, so let's see. 4 minus 1 gives me a 3, greater than or equal to 6. So once again, true or false?
False.
All right, so y'all lighting up with a false. Good job. So that would be another no. We only got one more number. That's 16. So let's see what 16 will do. That'll give me 16 minus 1 has to be greater than or equal to 6. Hey, also left side again, that's going to give me what? 15 greater than or equal to 6. True or false? Oh, y'all done got it up there. Good job. That is definitely true. So since that's true, that means yes, 16 would be a solution. Now, it looks like to me, since that's a 6 there, the smallest x I could have that would make this true would be a 7, right? Because 7 minus 1 is 6, and 6 is greater than or equal to 6. So that would make the equal part true. And then any number bigger than 7, such as 8, 8 minus 1 gives me 7, which is greater than 6. 9 minus 1 gives me 8, which is greater than 6. So you can have more than one solution on these type problems, okay? There's an infinitely many x's I can put in here, subtract 1, and that would be greater than or equal to 6. So, but of the 4 numbers they gave me, only one of those was the actual solution, okay? So, y'all, what I'm going to teach you about next is what we call interval notation. I'm going to turn this page. All right, let me move my camera back up. Because it's too hard to write solutions when there's more than one that work. Because like I said, any number bigger than 7 on that problem would have gave me a true statement. But I don't want to have to write x equals 7, 8, 9, 10 forever. Because remember, all those answers would make it true that were bigger than 7. So what we use to help us is what we call interval notation. So in interval notation, if we have greater than or equals or less than or equals, if it's got equals under those inequalities, we're going to use brackets for our intervals. If it's greater than or less than, we're going to use curvy parentheses. So when I got equals, I make them brackets like the square brackets, because that means the number is part of the solution. Now, when there's no equals, I use the curved parentheses, because that means the number is not part of the solution, okay? Now, let me ask you this. If I had a number line and say here was 0, 1, 2, 3, so I'm getting bigger to the right, I'm going to get more negative as I go to the left. But my question is this, y'all. As I get bigger and bigger and bigger to the right, the further I keep going right, what do we say we're heading towards? Infinity. Good job. So to the right, we're heading towards positive infinity. And then how about to the left? The further I go left and I go left and I keep going, I can keep subtracting. I'm headed off towards negative infinity. Good job. So y'all, let me show you how I use these brackets and these curves. Okay. So for an example, let me say, I'm going to write x is greater than or equal to a 3 in interval notation. So now here's the thing. On infinity, infinity always has the curved parentheses, because remember, there's no stopping point on infinity. So since infinity keeps going, we will always use the curvy parentheses around the infinity part. But for this 3, y'all see I got a line under that, right? For equals. So since I got equals on this one, my left bracket would be a solid bracket. And then I would put in my 3. Now this is saying greater than. So from 3, if it's greater than, what am I heading out towards? Well, y'all, I'm headed out towards this positive infinity. And remember, infinity always has the curved parentheses. So this interval right here tells me, since 3 is in a bracket, 3 makes that true because 3 is greater than or equal to 3. And then this tells me that any number from 3 heading out towards positive infinity makes that true. 4 is greater than 3. 5 is greater than 3. 6 is greater than 3. So anything to the right, there you go, is going to definitely head off towards infinity. So y'all, let's play with this again. How about if I had x was less than a negative 2? So remember, negative 2 has to be my largest number, which means negative 2 is going to be sitting over here on this right side. And it's in a curved parentheses because it makes this false. Negative 2 is not less than negative 2. Now, if that had an equals under it, I would use the bracket because that would have made it true. And y'all, less than, since this is pointing left, this inequality, where do I come in from as I head up to this negative 2? How can I represent all these negative numbers to the left side? Well, y'all, this thing here tells us as we go left, we're headed towards negative infinity. So this would start at negative infinity and go up to my negative 2. Also, my infinity looks a little crooked here. Okay. Now, just remember, infinity's always got to have a curve because remember, there's not a stopping point on it, okay? All right, y'all. Equals, I use brackets. If there's not equals, I use curves. Less than starts at negative infinity and heads to the number. Greater than starts at the number and heads towards positive infinity. So let's play with some of these. I'm going to do some of these like the homework will have. So the first one, they want us to write x such that x is greater than 1 in interval notation. All right, so they tell you what the variable is. This bar means such that. And then x is greater than 1. So what we're really focusing on is this part right here. How can we write x is greater than 1 in interval notation? Well, y'all, we're going to start off. Remember, greater than heads towards infinity. So the smallest number is that 1. So y'all think about this. Around that 1, am I going to put a bracket or a parenthesis? Good job, Dan. That's going to be definitely a parenthesis because I don't have an equals under that, okay? All right, then from 1, it's headed off towards, what do y'all think? Infinity. Good job. And remember, infinity always has a curve. So y'all, let me show you what else they're going to do to you. And see what y'all do with this. We're still going to write in interval notation. But this time they're giving me x such that -3 is less than x is less than or equal to a +3. So notice they're giving me the 2 endpoints on this one. I just got to figure out whether I'm using parentheses around them or brackets. So if -3 is my left endpoint, would y'all put a parenthesis around this number or a bracket? Oh, good job. I think you meant parenthesis with that 9. I think you forgot to shift it, but yeah, there you go. So yeah, look, this part right here does not have an equals under it, so that's got to be the curve. Now, the right endpoint is a 3. What would I put around that 3? And y'all, I'm looking at this side. This side has equals, so definitely, there you go. It's going to be a bracket. So y'all make sure these numbers are your endpoints, and then look at the inequality associated with that number to tell you whether it's going to be -3, a parenthesis, or a bracket. All right, so let me try one more of those, and then we'll play with the number line stuff. So write this one. X such that -4 is greater than x, which is greater than -8. So y'all, let me tell you a trick on this one. They've got the numbers reversed. So what I'm going to do on this one, I'm going to put this in the correct order. Because we always want to read those intervals from left to right. But y'all, -8 is smaller than -4. So they got the order backwards. So to reverse this, I'm going to bring my -8 out. Notice this inequality is pointing toward the -8. So when you reverse it, it's still got to point toward the -8. Then you're going to put your x. So the -4 is going to be on this side. And notice on the -4 side, the inequality is pointing toward the x. So when I rewrite it, my inequality's got to be pointing to the x. So since this one's out of order, the correct order would be -8 is less than my x is less than my -4. Okay, so you always want your smallest number first and then your largest number to the right. So y'all, we got two endpoints. Here's my -8. Do you want a parenthesis or a bracket? And let me see what Zion and Deanna got. Oh, y'all are perfect. Because there's no equals under these. So both of these are definitely going to have those parentheses. And then -4 over here with our parentheses, okay? So just watch them. That's one that they try to trick y'all on by putting that one out of order. All right, y'all. So let me show you this now. Let me get my papers curling. So next, what they wanted you to do was write interval notation given a graph. So we're going to write interval notation given a graph. So y'all, let's see. This one, I've got a number line. So let me start my 0, 1, 2, 3, 4, and then I'll go negative this way. Now y'all look what they got. Over here at -1, they got a curvy parenthesis. Over here at 4, they got a curvy parenthesis, and it's shaded in between. So this is basically another way to represent the solutions with a number line. So y'all, if we're writing this in interval notation, I'm going to tell you the truth. It's going to look exactly like this number line. If the number line's got curvy parentheses, my solution will have curvy parentheses in my interval, okay? So for this one, I got a curvy parenthesis at -1. So I'm going to bring down my curvy parenthesis, put my -1. Then you're perfect because the right side is a 4 with a curvy parentheses. So the interval will look exactly like the number line, okay? All right, so I want to trick it up on y'all and see what y'all do with this. Right, interval notation again. All right, y'all, so let me see where they're starting this one at. Okay, I got it. So 0, 1, 2, 3, 4, 5, 6. I'm gonna go out about 7 on this one. And I guess about -5 on the left side. So y'all, what they did to this one, right here at 2, they got a bracket. And then it is shaded all the way to the right like this. And my arrow is shaded also. So what y'all think that one is? And we're starting with 2 for the left side, right? So here's my 2. So on the 2, do y'all want a parenthesis or a bracket? So I do want a bracket. Good job. Now, oh, let me get one in. All righty. So now I got my bracket. Oh, I think I accidentally hit Paris accidentally hit shift on that one. But yo, look where it's headed. It's headed to the right. And that arrow keeps going and going and going. So what's it headed off to? Infinity. There we go. And remember, infinity will have a curve on it. All righty, y'all. So now we're actually going to solve some equations. And then they'll have us write the answer we get. And then they're going to have us pick one of the 4 graphs that shows our answer, okay? So pretty much doing what we're doing up here. So we're going to solve and graph the inequality. All right, so a plus 6 is less than or equal to a negative 17. So we're going to solve this first, because the way they write the answers first, they got a such that a, and then we got to pick the symbol and our answer, okay? So first off, I want this a by itself on the left side. So y'all got one move on this problem. So what did we do when they were adding numbers and we wanted to move them? Oh, yeah. Subtract opposite sides. There you go. So I'm going to subtract a 6 from both sides. So I get my A. My 6 and negative 6 on the left side are going to cancel. And then I bring down my less than or equal. And y'all, let's see. Negative 17 and a negative 6. Like terms, like signs, add and keep that sign. So that's going to give me a negative 23. So right here, we would choose the one that had the less than or equal, and then put in our negative 23. So this one, they're not making you do the interval notation. They're just wanting you to pick the right symbol and then put in the answer, okay? So on the number line, I'm not going to draw 0 all the way out to negative 23. What I'm going to do is put my negative 23 here. Here's negative 22, negative 21, negative 20 that way. To the left, negative 24, negative 25, negative 26, and so on. Now remember, this is less than. So this inequality is going to point to the left. The largest number that this can be is this negative 23 here. So on that negative 23, would y'all use a parenthesis or a bracket? And y'all, I'll tell you a trick on these. These little inequalities, they point the way you're really going to shade your line, okay? So y'all said brackets. So at negative 23, I'm going to put me a bracket here. And then it says any number less than or equal to that negative 23 makes this true. So remember, less than is going to shade to the left. And we're done. So y'all, they're not too bad. So So this is telling me any number less than or equal to that negative 23. That solution telling me the same thing. All right, y'all, let me pick out some more of those. Let me try this one. We're going to solve and graph. So this one, I'm going to do 2x greater than or equal to 14. And same thing, I'll write the answer in what we call set builder, and then I'll graph it. So we got one move on this one. Since that 2 is being multiplied by the x, and I need to turn that 2 into a 1, we're going to come in and divide both sides by 2. And that'll give me 14 divided by 2. All right, good job. I see a 7 up there. So that's going to give me my x greater than or equal to a 7. All right, y'all. So in your set builder notation, you would have x such that x is greater than or equal to 7. My number line. So let's see, 7 is my number. So I'm going to put it in the middle. Here I'll do, say, 6 and 5. This side I'll do an 8, 9, and a 10. So 7 is the number we're looking at. Parentheses or bracket. So it's definitely a bracket. Now remember, greater than shades to the right. And that's the way that thing's pointing anyway. It's pointing right. So at 7, I'm going to put a bracket and shade to the right. And y'all, there we go. Now, let me show you one where you do have to worry about one thing. So I'm going to solve and graph again. But y'all, this time I got a negative 2x greater than a 4. Y'all, this is the only time where you got to worry about what's happening here. And there's a little rule on these inequalities. If we have to divide by a negative number, in front of the variable, then we must reverse the inequality. So you notice I'm dividing by negative 2 because that negative 2 divided by negative 2 is going to make that a 1x right there. So when I come down here, and at this point, I'm dividing both these sides by a negative number, that means this greater than has to turn around and become a less than. You got to reverse that every time you divide by a negative number. So y'all watch this. Negative 2 divided by negative 2 gives me 1x less than 4 divided by negative 2 is a negative 2. So let's think about that. My numbers has to be less than negative 2 to make that true. So negative 3 is less than negative 2. So negative 2 times negative 3 give me a positive 6. And 6 is definitely greater than 4. Negative 4 is less than negative 2. Negative 2 times negative 4 is 8. 8 is greater than 4, which is true. So that's why when you divide by these negatives, you gotta reverse that to make these true, okay? All righty, y'all. So that would be x such that x is less than -2. And then our number line. So I'm gonna put -2 here. And then -3, -4, -5 to the left. All righty, y'all. So the first thing, -2 is my number I'm concerned with. At that -2, parentheses or bracket. Oh, so y'all let me get you. Okay, there we go. I start seeing some parentheses because remember, there's no equals under that. So it's going to be parentheses. So here's my question. Am I going to shade this thing to the left or am I going to shade it to the right? Well, remember, less than shades left, good job, and then greater than would shade right. And you see, once I got this solved from a variable, this little inequality, it points the way you're going to shade every time. So at -2, I would put my parentheses and shade this to the left. And if y'all look at every one of these, when we got these solved, that's pointing the way this thing's shaded, okay? All right, same thing. We're going to solve. Oh, and y'all guess what? They don't want me to graph them no more. So for the last 4 or 5, we just got to solve the following inequalities. So -7x greater than or equal to a -4.9. All right, so all I got to get is the answer and we'll be done. And I'll put it in this set builder notation here. So to solve this, since I'm multiplying -7 times the x, I'm going to divide both sides by that -7. And y'all, what else do I got to do? Flip it. There you go, because we're dividing by negatives. So the greater than or equal now becomes a less than or equal. All right, that gives me my x less than or equal. Ooh, that's going to be a positive something. What is a 4.9 divided by 7? Looks like I'm getting a 0.7. So x has got to be less than or equal to a 0.7. Y'all remember, these two negatives, when you divide two negatives, that does become a positive. So on that one, y'all would pick the one that said x such that x is less than or equal to 0.7. All right, y'all. 6y plus 2y is less than or equal to a -48. So let me ask y'all something. What is the first thing we need to do to this problem? And y'all, what I want y'all to focus on is this left side over here. Yeah, so to get this y alone on this left side, I'm going to add the 6 and 2. Okay, so the first thing I'm going to do is combine those like terms. So that's what I'm going to do with that. So we got to combine like terms. So anytime you got more than one y on one side, add those like terms together. So 6 and 2 give me 8y. And 8y is going to be less than or equal to a negative 48. Now, Deanna, I don't actually want to subtract this from the negative 48. There you go. I'm going to divide it. So I'm going to take 8y divided by 8. That's going to be less than or equal to negative 48 divided by 8. Notice, I divided by a positive number, so I did not flip that inequality. I'm only flipping it when I divide by a negative. Oh, y'all got a negative 6. So let's see, y less than or equal. There you go, negative 6. So y such that y less than or equal to your negative 6. All right, y'all. So I got one more in this section, and then we'll move into 3.3. So the last example for this section is a 4y minus 2 less than a 7y minus 3. All right, y'all. So guess what I'm going to do? I'm going to get my y's on this left side, my numbers on the right side. So to move all the y's to the left side, since this y is positive, I'm going to subtract 7y from both sides. And on these inequalities like this, I always try to get my variable on the left side. That way it points the way I got a shade if I had to do that graphing, okay? So 4 minus 7, that's going to give you negative 3y minus 2 is less than negative 3. So now the y's are over here. These numbers, I want to move all the numbers to the other side. So since that 2 is being subtracted, we're going to add 2 to both sides. Okay, so these 2's now cancel. So I got my negative 3y is less than negative 3 plus a 2 gives you a negative 1. All right, y'all. So my last step, divide both sides by that negative 3 to turn this into a 1y. And guess what? I'm dividing by negative. So now I got to flip that inequality around, and this now becomes a greater than. So remember, flip the inequality. When dividing by negative. All right, so guess what? Negative 3, give me 1y greater than. Oh, y'all, look at that. A negative 1 divided by negative 3 is going to become a positive. And actually, Xeon on this one, actually, they just want you to leave this as a positive 1/3. So the only time they're going to let y'all put a decimal in for the answer is like that one I did a while ago with the 0.7 and that 4.9. That's the only kind. If they give you a decimal, they'll let you write the answer as a decimal. But y'all, any other time, they're just going to make you write it as a fraction, okay? All righty, so that one would be y such that y is greater than 1/3. Y'all, that's 1.4. It mainly deals with these inequalities. But now I ain't gonna lie, we got a fun one coming up if you like doing math. So the last section for test one. So what we'll do, this is the last section for test one, because for this course, we only like to do a few sections at a time and then test. So what we'll do next week, we'll review some of this test and get y'all going on it. So the test ain't due this weekend. It's going to be due the next Sunday, okay? So this week, we just got to concern ourselves with these first 4 assignments. So this is 3.3 homework, and this deals with solving systems of equations. So there's a few steps on this. The first step I do, I pick a variable to eliminate. So I'm going to pick, because these are going to have X's and Y's in them both, okay? So we pick a variable to eliminate. Once we eliminate that variable, we solve for the remaining variable. Once I solve for that remaining variable, I'm either going to have an X equals something or a Y equals something. So now to get the other variable, I back substitute into either of the original equations and solve for the variable. Now, the last thing you always want to do, check if needed. So to check, you plug in what you got for the X, plug in what you got for the Y, and see if that is a true statement. But y'all watch out for a certain thing or two. If we end up with a false statement, then there is no solution. So a false statement would be something like 5 equals 7, -2 equals 3. If you end up with something like that, then it's a no solution. The other case is if we end up with a true statement, so by a true statement, if you end up with something like 5 equals 5, X equals X, if you get a true statement, then that means there is infinitely many solutions. And y'all, I'll show y'all examples of both of these things here, okay? So here we go. Y'all, these are fun, especially when you get the right answers. It's like, whoa, these are fun, okay? Now, here's the thing. We will do these in college algebra when y'all get there, okay? And actually in college algebra, we do 3 variables. We do X, Y's, and Z's on some of those, okay? So it's going to be similar to these, but a little more work once we get into that actual college algebra. So here we go. We're going to solve by the elimination method. And we call that elimination method because we're eliminating one of the variables when we start this. So y'all, I got an X plus 5Y equals 28. my next equation is a negative x plus 6y equals 27. So that's my little system of equations. Now, to eliminate variables, we add these two equations together. So if you notice on this first example, I've got an easy variable to eliminate. We're going to eliminate the x. Because I got a positive x and a negative x. When I add that negative x and that positive x, they're going to cancel. So guess what? Those cancel out right off the bat. So what do we get when we add the 5y and the 6y? Well, y'all, that's going to give me 11y. And then we got 28 plus 27. That's going to give us 55. So by adding the equations, that's how we get rid of those variables. All right, y'all, you're left with 11y equals 55. So now solve for that remaining variable. I got one step to do to get this to be a 1y. What's that move? Okay, there you go. Divide by the 11. Good job. So 11y divided by 11 equals 55 divided by 11. So y'all, that's telling me y equals 5. So I know what the y equals. Now I got to get my x. So the x, I can use either one of these equations. So I'm going to use the first one. So this is where I'm going to back substitute. And since I know y is 5, I'm going to put a 5 in for that y. So I got x plus 5 times 5 equals 28. So there's my 5 I plugged in for the y. So I'm going to have x plus 5 times 5 is what, 25? That's going to equal the 28. All right, y'all, guess what? You got one more step. How can I get my x by itself now? So y'all, you gotta, okay, so you looks like you're doing what I needed. You're going to subtract that 25 from both sides. So that I get x is equal to a 3. Now, here's the thing on these. Since I got an x and a y, we write the answer as an ordered pair. Now remember, ordered pairs looks like the coordinates when you're graphing. Ordered pairs are going to be in parentheses, but remember, you got to put the x first and then the y. So since we got an x is 3 goes first, and then the y was a 5. So remember, you always want your x first and then your y. If I gave me A's and B's, I would put my A first and then my B. So y'all check this out. If I put a 3 here, 3, and put a 5 here, 5 times 5 is 25, plus 3 equals 28. That checks out, so we're good to go. And you can put this 3 and 5 into either one of those equations, and it'll be a true statement, okay? So let's play more. Now, they're not always going to be this easy in the very beginning, okay? But we got lucky that they gave me an x for one equation and a negative x for the other. So what's going to happen when they're not that easy? So let me get this fixed. Flip my paper over there till it curls on me. All right, y'all. So same thing. This time I got a 3x plus 4y negative 11. I got a 6x minus, whoops, let me see, I got offline. 3x plus 4x equals negative 11. This one should be a 4x. So that's a 4x minus y equals negative 2. So here's what we got to do. We got to pick which variable we think would be easier to eliminate. Now notice 3 and 4 are both positive. That is not going to eliminate. If I add them, that's going to give me 7x. 4y and a negative y, that's going to give me 3y. So that one's not eliminating. So I got to change one of these equations so that I can get one of these to eliminate. So y'all, let me show you what I'm going to do. I'm going to eliminate the y. Now check this out. Right here, you got a positive 4y. Down here, I need to get a negative 4y. So since that's a negative 1y, and I want that to be a negative 4y, I'm going to multiply the second equation by 4. So you agree, if I multiply this whole equation by 4, negative 1 times 4 will give me a negative 4y, okay? So the first equation, I'm not changing, I'm bringing it down. Y'all, if you multiply this second equation, everybody gets multiplied. What's that going to give me? All right, y'all, so let's play with this. 4x, okay, I see it now. So Dana, what do you got? Okay, because 4 times 4 is 16x. 4 times that negative y gives me a negative 4y. Good job. And then 4 times negative 2 is negative 8. So Deanna, we don't put question marks after our answers. We have confidence, okay? So good job. All right, y'all, but look what. These y's now cancel. Those y's are canceling when I add them together. 3x's plus 16x's gives me 19x's. Negative 11 plus a negative 8 give me a negative 19. So now I got one variable. We're going to solve this by dividing both sides by that 19. And y'all look at that. That cancels, giving me my x equals a negative 1. So now that we know x is negative 1, we can back substitute. And I'm probably just going to grab that first equation I had. So x is negative 1, so that's going to give me 3 times negative 1 plus 4y equals negative 11. And you'll notice when you plug it in for these variables, the first step is usually going to be that little bit of multiplying. So 3 and negative 1 give me negative 3 plus 4y equals negative 11. All right, y'all, we're down to 2 steps. First, we're going to add 3 to both sides. That way we can get that 4y by itself. And y'all look what happens. I get 4y equals a negative 8. Divide everybody by 4. And there we go. That cancels, giving me y equals a negative 2. So let's see if y'all can write my final answer in ordered pairs. What y'all going to get? So -1, -2, good job. Remember, always has the X first and then the Y. So these aren't too bad. You just got to pick out what you're going to get rid of. And then start getting rid of them, okay? So let me try one like this one here. This one I got a 4x plus 5y equals 4. I got an 8x plus 10y equals 8. So yes, Shatia, after we get done, it usually takes me about 45 minutes to get them posted. But I'll put it in Blackboard and I will send y'all a link to it through your email. All right, y'all. One of y'all tell me, do we want to get rid of X's or Y's? And it don't matter which one we get rid of. So what do y'all want to go with? All right, so we're going to eliminate the X. So I got a 4x here and an 8x here. So I would probably change the top row. So what do y'all think we need to multiply the top equation by? Oh, you're so close. So then I like that too, but remember, that'd give me 8x and 8x. So instead of a +2, I would multiply that by a -2. Because remember, I need one of these positive and one of these negative in order for them to cancel. So we're going to multiply the top equation by -2. So let's see what that gives us. 4 times -2 is a -8x. 5 times -2 is a -10y. 4 times -2 is a -8. And then the second equation stays the same. 8x plus 10y equals a +8. Woo, look what y'all done did to this one. What happens on that left side? So -8 plus 8 is a what? Big O 0. -10y plus 10y. That's a 0. So my left side is a big 0. Well, y'all look at the right side. -8 plus 8. That's a big 0. So the question is, remember, when the variables go away, you got to determine if this is a true statement or is it false. Well, 0 equals 0. You can't get more truer than that, can you? So remember, since that's a true statement and the variables are gone, that means that this system has infinitely many solutions. Now, if I would have got rid of all my variables and I had something like 0 equals 5, 0 equals 5 is false, and that's when we would have had a no solution, okay? All right, y'all, so let's see. Turning the page. All right, let's try this one. Oh, where'd I go? 3x minus 6y equals 3. 3x minus 6y equals 4. So there's my system. What do y'all want to get rid of? X's or the Y's? So let's see. I got an X and a Y. So let's see. Last time I did the X's, didn't I? So hell, we'll just eliminate the Y this time. So notice this. I got a -6 here and a -6 here. One of these rows needs to become positive. So to make that -6 a +6, I'm going to multiply the top row by a -1. Anytime you want to change signs, you're going to multiply by -1, okay? So watch this. I'm going to multiply the whole top row by that -1. So that's going to give me a -3x plus a 6y equals a -3. My second row does not change. 3x minus 6y equals 4. Oh boy, look at my left side again. -3 and 3, those x's cancel. 6y minus 6y, those cancel. So y'all, my left side is a big 0. My right side has a -3 and a 4. So 4, -3, give me a 1. Oh, good job, Zion. That is definitely false. And since that's false, perfect. This is a no solution. So y'all, let me give you one more, and then we'll call it a night. So I got a 4a plus a b equals 18. I got an a plus a 4b equals a -18. All right, so pick a variable, to A or B. So I'm going to eliminate the A. So to eliminate A, since this has got a +4a, this bottom one needs to be a -4a. So I'm going to multiply the second equation by what? So what would y'all multiply that second equation by to make that a -4a? So good job. We're going to multiply all of those by -4. So remember, my top equation is not changing. So I got 4a plus b equals 18. Multiplying by -4, I get a -4a minus a 16b. Ooh, and let's see, -18 times -4. That's going to be what, a +72. All right, good job, y'all. Look at that. The A's cancel. 1 minus 16 gives me a -15b. Whoa, let's see, what is 72 and 18? That's going to be what, a 80, and 10 is 90. All right, y'all. So this ain't going to be the no solution in the infinite solutions, because I don't have true and false statements here. I got variables. So I'm going to solve that b by dividing both sides by -15. So that cancels, giving me my b. Oh, that's going to be what, a negative. Y'all, how many times 15 going into 90? Let's see. 1, 2, 3, 4, 5, 6. So 6 means I get a -6 there. So I know what my b is. So now I'm going to back substitute. and get the A. So I'm just going to pick this first one again. So I got 4A plus my B. Well, my B is a -6. And all of that has to equal 18. All right, y'all, solve that for the A. First move y'all want to do is get rid of that -6. So to get rid of the -6, we're going to add 6 to both sides. So that brings down my 4A. That cancels. 18 and 6 gives me 24. All right, divide both sides by 4. So A equals 6. So y'all, how would y'all write that answer in ordered pairs? All right, so let's see. Oh, good job, because the A had to be first. So I was making sure y'all put the A first and then the B. So that one had to be in alphabetical order also. All right, y'all. So that is 3.3 solving systems of equations. So I'm gonna let y'all catch up on your writing real quick. I'll get this posted in about 45 minutes to an hour, and I'll have y'all email to send you. So do everything up to 3.3 by Sunday night. And then that'll keep you on schedule with me in this class, okay? So we'll come in next week. I'm going to sort of review you a little bit for the first test, and then we'll pick up with some new sections, okay? So I'll open your first test after our Tuesday night class, and you'll have all the way till that next Sunday to work it, okay? All right, y'all, so I'm going to quit my share now. All right, so do y'all have any questions over anything? So Deanna, I'll actually open it probably either Sunday, Monday, or Tuesday night. And y'all, I'll tell y'all something else. I got a review for the test in there. Do that review until you get a good passing score on it. Once you get a good score on that review, then knock out the test. Because the test and the review always have the same type questions, and they're usually in the same type order, okay? Oh no, so the end, it won't be due that Thursday, it'll actually be due that next Sunday, which will be what, June 11th, I think it is. Might be June 10th, but whatever that Sunday is after. Okay. All right, y'all, so I'm gonna quit this recording.